Welcome to Lesson 2.3, Solving Absolute Value Inequalities. We're going to begin on page 87 of your work text. Our essential question today is, what are two ways to solve an absolute value inequality? So yesterday's lesson was on solving absolute value equations. Now we're going to change that to an inequality. And just like yesterday, we can solve them either graphically or we can solve them algebraically. When solving an absolute value equation, you learned yesterday that it's possible to get two solutions. Here you're going to explore and see what happens when we solve an absolute value inequality. So here's our inequality. I'll grab my pen. And here are all the solutions. As you can see, it's an interval and not just specific points. It's all the numbers between -3 and 3 are solutions for the inequality. Here's another example. In this case, we want numbers, the absolute value, plus 2 is greater than 5. All those numbers exist, those solutions, are numbers less than -3 and numbers greater than 3. Turn to the next page, and if you'll direct your attention to the very bottom of the page where there's a graph, I'm going to show you how to solve an absolute value inequality by graphing it and looking at the graph itself. So this graph was created by graphing the left side of the inequality and then graphing the right side of the inequality like you did in the last lesson. And in the last lesson, you were looking for those point of intersection where they were equal to each other. Well, now we're changing it to an inequality symbol, and this inequality wants to know when the left side function is greater than the right side. So when is it greater than 4? So I'm going to go back to the graph here, grab my pen, and we want to know when the v function, I'm going to call it, is greater than 4. Well, that would be right here. So we're talking about the function, the y value, is greater than 4. Looking at the area that I highlighted, I want the x values for those intervals. So I can write the right side where x is greater than 0, and I'll put an or symbol here. And on the left side, it is when x is less than -6. This is our solution for the absolute value inequality. Let's try another one together. At the top of the next page, letter B, we have the absolute value of x minus 2, quantity, minus 3 is less than 1. So begin by graphing the left side, and then graph the right side. I've gone ahead and done this for you on the right side here, or you can use technology. If you've got an Inspire or a graphing calculator, feel free to use your graphing calculator. All right, this inequality is in the form of f of x is less than g of x. So the left function is less than the right side of the function. So when we look at the graph, we want to find the graph of the absolute value where it is less than 1. That means we're going to be looking for the part of the graph that lies below the g of x equals 1. Now where does it lie below? Let's highlight it. This is the area that our absolute value function lies below g of x equals 1. The x values that correspond are from -2 to 6. However, we're not going to include -2 and 6, but those are kind of the endpoints. So we're going to write the inequality where x is greater than sorry, this should be -2 here and +6. Got those mixed up. That should be x is greater than -2 and x is less than 6. Another way you could write that is -2 is less than 6, which is less than, sorry, x is greater than -2, which is less than 6. You might be asking, why are we not going to include the endpoints -2 and 6? And the answer comes from right here. We want the value when it's less than, not less than or equal to. So in that case, we're not going to include the endpoints. At this point, I want you to try problem number 6 at the bottom of that page, under your turn, where it says solve this inequality graphically. Feel free to use your technology, either Desmos if you have access to that, or an Inspire or graphing calculator. Turning to the next page, we're going to learn how to solve absolute value inequalities algebraically. Now the method your textbook shows you, and most textbooks show you, is mathematically correct. However, rather than teaching you some new rules, I'd rather just use the skills that you already have for solving absolute value equations and just using our number sense to come up with the solution. So this is where I need you to take out a separate sheet of paper and copy down the notes. Okay, so our inequality is going to be the absolute value of 4 minus x plus the quantity 15 is greater than 21. Alright, so just as we learned in solving equations, let's isolate the absolute value expression. So I'm going to subtract 15 from both sides. And I get the absolute value expression is greater than 6. Okay, we're going to, at this point, solve this as an equation in order to find our endpoints. So I'm going to write 4 minus x equals a positive 6, or 4 minus 6 equals a negative 6. Solve both equations. I'm going to subtract 4 from both sides, and my first endpoint is going to be x equals -2. On the right side, subtract 4, divide by -1, and I get x is equal to 10. Okay. These are not my solution. These are the endpoints of the intervals that we're going to graph. So if I have a number line, and I'm just going to, let's see, here's my number line. -2 is down here. And I'm going to put 10 up here. And just for the sake of things, I want to stick 0 in there, because I like to do math with 0. Alright, since this is a greater than symbol, we do not want to include our endpoints. So we can go ahead and put open circles around -2 and around 10. Now all we need to know is which interval do we shade in. Do we want this interval over here? Do we want the interval between the endpoints? Or do we want the interval to the right? And the way we find out that answer is simply plug in some numbers into the original equation. So I'm going to move this down so I can have a little bit more room to write. So let's take a number in the left-hand range. Let's take, let's make it x is equal to -3. Substitute that into the original inequality. And check to see is that true. Well, we end up with 7 plus 15, absolute value of 7, plus 15 is 21. That actually gives us 22 is greater than 21. That is true, meaning we want the interval with -3. So that means we're going to definitely shade the area with -3 up to our endpoint. Well, what about 0? We let x equal 0. Substitute in 0, you get 4 minus 0 plus 15. Is that greater than 21? And if you simplify that, no, it is not going to be. So we do not want the interval with 0. So then let's try x is equal to a number greater than 10. You could use 11, 12. What if I use 20? It's greater than 10. And I substitute in 4 minus 20, absolute value, plus 15 is greater than 21. All right, the math inside the absolute value bars gives me negative 16. That becomes a positive 16 plus 15 is greater than 21. And yes, that is true. So we also want this interval greater than 10. So we have our solution graphed on the number line. Now all we have to do is actually write it algebraically. So we can write the left-hand solution as x is less than negative 2, or x is greater than 10. And this is our solution. Let's try another one together. Going back to our work text on the next page, the top of page 91, let's try your turn number 9 together. Let's see, in this problem, number 9, the first step is to isolate the absolute value expression. So we're simply going to divide both sides by 3, and we get the absolute value of x minus 7 is greater than or equal to 3. All right, our next step is to solve for the two endpoints. So we have x minus 7 equals a positive 3, or x minus 7 equals a negative 3. Solve both of those equations, add 7 to both sides, we get x equals 10, or x equals a positive 4. Since this inequality has a greater than or equal to symbol, we want to include those endpoints. So go ahead and we're going to put a closed circle at x equals 10 and an x equals 4. Now we have to figure out which interval do we shade. To determine the left side, I'd probably use 0. Substitute 0 into the original inequality. Does it make a true or false statement? I'm going to let you do that math. Then substitute in a number between 4 and 10. Any number you choose, see if it works in the inequality. Then choose a number somewhere above 10 and see if any of these numbers work in the inequality. If they do make the inequality true, then you want to shade that interval. Okay, I determined that 0 is a solution, so I'm going to shade to the left of x equals 4. All right, and I also determined that the numbers above 10 are solutions, so I'm going to shade the numbers above 10. So there's our solution graphed. Now we need to write the solution algebraically as an inequality. So as you learned in Algebra 1, this is a compound inequality, and we're going to say x is less than or equal to 4, or, and we do need to put that word or, x is greater than or equal to 10. And that is our solution set. It's your turn to try one on your own, so go ahead and answer number 10.